Welcome to the Crazy Hat Chemist. So today we're doing the 15th video on nuclear chemistry, and we're going to do graphics. Bam! We're going to do a graphic of radioactive decay. So take a look at this graph. Okay, on the x-axis, which is on the horizontal, is the age of the sample in years. Really simple, 0, 1, 2, 3, 4, 5, all the way to 8. On the y-axis, that vertical one, we have the percent of radioactive sample yet remaining. And notice that this graph goes like that. Okay, it starts off here at 100%. So that's like at time 0, and at year 0, I have 100% of my sample. That's the initial amount. So it's like taking this full sheet of paper. I got a full sheet of paper originally. So in a half-life, that would be 1 year in this case. In 1 year, in a half a life, I have 50% remaining. So that's like taking this sheet of paper and cutting it in half, and then this is how much remains. I have 50% remaining of my original sample. Okay, now what I'm going to do is I'm going to take this here, and in another year, so a total time of 2 years, I am going to have 25% of my original sample. This was 50%. I'm going to divide that into 2, and now I have only 25% of my original sample. Hopefully that made sense there, right? Here's my original sample right there, a full sheet of paper, and then here's my 25% remaining here. Hopefully you can see that. Yeah, that works out. Okay, if I keep on going, if I add another year, another half-life would be another year, so a total time of 3 years. I'm going to take that, and I have 12.5% remaining. Okay, I can do that one more time again in 4 half-lives. Okay, I have 4-year total time and 6.25% remaining. Notice that I'm taking my percentages and I'm dividing it by 2 each time, dividing it by 2, dividing it by 2, dividing it by 2, dividing it by 2. As far as the time, I'm adding the half-life together each time to the total amount of time in which I have. Okay, let's do another one here, but this is for carbon-14. Notice that on this graphic, on the x-axis, I have age and sample of years, okay? And I have 0 and 5,000, 10,000, 15,000, 20,000, 25,000. On the y-axis, the vertical axis, I have the percent of carbon-14 yet remaining. Remember, carbon-14 is the only isotope, naturally occurring isotope, of the 3 isotopes of carbon, carbon-12, 13, and 14, that is radioactive. This does not work with carbon-12, it doesn't work with carbon-13 because they're not radioactive. It only works with radioactive samples. So, that's what I have at time 0, at that 0 years, how much do I have? 100%. Okay, in a half-life, and the half-life for carbon-14 is 5,730 years. So in a half-life, how much remains? 50% of the original sample. Okay, and then in another half-life, so I'm going to take 5,730 years plus 5,730 years, and I will get 11,460 years. And I will have 25% of the original amount remaining at that second half-life time frame. Hopefully that makes sense for you. You can keep on going with this graphic here. Okay, and in a third half-life, so I'm going to take the 11,460 and add 5,730, and I will get 17,190 years. Okay, and that will have 12.5% yet remaining of that original sample. Okay, this is not wizardry at all. This is really simple stuff. Okay, I am the wizard, however. Most certainly the wizard. Give me a thumbs up if you like that video. Subscribe to my YouTube channel, and I will see you next time.